Right, okay, so here is the mechanics question we looked at. So we've got our plank being held by our inextensible string against the wall. Okay, so we're told a few things. We are told that tan of alpha is 3/4. So whenever we're told that in a mechanics question, that means that opposite over adjacent, that's my alpha. So that must be 5 because it's a Pythagorean triple. So now I know what cos of alpha and sine of alpha are. So my cos is 4/5 and my sine is 3/5. Now, my diagram is missing a few things. As this is 2a, I've got the weight because I am told that this is this has mass m. Okay, and I'm told that P, my block, has a mass of 3m. Okay, and they're both being acted on by gravity, so they're both going to be mg. Right, okay, and we're also told, obviously, this is an important thing, that it's modelled as a uniform rod, so I can assume that mg is a from the wall, because the overall length of the plank is 2a. Right, great. Okay, so now I've got everything in place. Okay, so now for A, we've got to use the model to show the tension of the rope is equal to that. Right, okay, so for A. Okay, so now I'm going to use A as my pivot, and I'm going to resolve vertically. So the vertical component of my tension is T sine alpha, and as A is my pivot, the distance from the pivot is 2a. Okay, now what else have I got? I've got mg, okay, the weight of the plank, and that's A from the pivot. I'm going to add to that my 3 mg for the block, okay, and that is x away from the pivot. Okay, so now I'm going to replace my sine alpha with the value that we found from our triangle, which is 3/5, and that's multiplying 2a, and I'm going to factorise mg out of the other side, so I've got a plus 3x. Okay, well, we can see that's already starting to look like the thing that we want. Okay, so now I'm just going to divide by the things that are multiplying t to get my t value. So on this side I've got mg, I'm going to reverse these two because they're added, so it makes no difference of the order I put them in, 3x plus a, and I'm going to divide that all by 6a/5, okay, which is basically just the coefficient there, but we all know that fractions don't have 3 tiers, so if I divide it by 69/5, that actually gives me 5 mg 3x plus a, all divided by 6a, which is exactly what I want to show. So that's a taken care of. Now, they tell me the magnitude of the horizontal component of the force exerted on the plank at A by the wall is 2mg. Okay, now I've got to find x in terms of A. Okay, so B. So we're going horizontally. And I know that my reaction force has to be equal to T cos alpha, because they're the only forces in the horizontal plane. So now they just told me that R is 2mg, and that has to be equal to T, which we just found, is 5mg 3x plus a, all divided by 6a, times cos of alpha, which again comes from our triangle that we worked out earlier. So that's 4/5. And when we multiply all that out, that gives me 20 mg 3x plus a divided by 30 a, And obviously I can divide through by 10 and I've got 2/3. Right, okay. So now I've got 2mg equals 2mg 3x plus a all divided by 3a. And again, I'm going to divide by 2 both sides. I'm going to divide by mg on both sides. Now remember, on the left hand side, even though I'm dividing through, that's still going to leave me with 1 because mg divided by mg is 1. And then on the other side, now what we've got left is 3x plus a all divided by 3a. So let's multiply out the fraction. 3a is equal to 3x plus a. So 2a equals 3x. And therefore, x equals 2a divided by 3. And now I've got x in terms of a. Right, now, the force exerted on the plank at A by the wall acts in a direction which is which makes an angle beta with the horizontal. Okay. So let's start here. Okay, so let's see. Now, if I get to a force acting in 2 different planes, a vertical and a horizontal, I get a resultant force. So I've got the horizontal force. Let's look at the vertical force. So again, T sine alpha, the vertical component of my tension, plus V equals 4mg, which is the total vertical weight. Okay, so now I know what T is. So again, I put my 5mg 3x plus a all over 6a, and I multiply by sine alpha, which is 3/5, and then I've got my my force in the vertical distance, the vertical plane, okay, and that's equal to 4mg. So I rearrange that. V equals 4mg minus my T, which is, when I've multiplied these two together, I end up with mg 3x plus a all over 2a. But earlier on we worked out what x was, so let's sub that in. So V equals 4mg minus mg, and x we said was 2a over 3 plus a all over 2a. And when I simplify that, I get that V equals 5mg over 2. Okay. Right, so now I've got that. So now let's think about this. I've got my horizontal force, I've got my vertical force, and then I've got my diagonal, my resultant force. Okay, so I know now that my vertical force is 5mg over 2. I know that this is equal to 2mg. So I simply put those into tan. So tan of beta is equal to 5mg over 2 divided by 2mg. And we know from some simple basically fractions, okay, 5mg over 4mg, and therefore I can cancel the common factor of mg, and tan of beta is just 5 over 4. So that's C taken care of. Right, now the last thing, it says the rope will break if the tension in it exceeds 5 5mg. We'll explain how this will restrict the possible positions of P and justify your answer carefully. So justify means we have to show how we work that out. Right. Okay, so now let's go to D. Stick with one colour. Right, so D. So that means that tension has to be less than 5 mg. Okay. So now tension, we know what tension is. We work that out. 5 mg, 3x plus a, all divided by 6a, and that has to be less than 5 mg. Okay, and then we'll divide through both sides by 5 mg. So that means that 3x plus a over 6a has to be less than 1, and therefore that 3x plus a has to be less than 6a, and therefore that 3x has to be less than 5a, and therefore x has to be less than 5a over 3. Now, we've got to explain what this means. It means that P can't be more than 5a over 3 from A. Okay, because remember basically that P is positioned x away from A. So if it's more than 5a over 3 from A, then there'll be a problem and it's going to break. And that takes care of D.